The meaning of differentiation. Differentiation is a fundamental concept in calculus. What it measures, differentiation is the process of finding the instantaneous rate of change of a function. In simple terms, it tells you how fast one quantity is changing with respect to another. The result of differentiation is called the derivative, usually denoted as dy over dx. Okay, so now we're moving on to the question 2a. So the question 2 asks, find the dy over dx for the following function. So our function for question number 2a is y equals to 2x squared and exponent sine 3x. So firstly, we need to determine which rule we are going to use to solve this particular question. So I already determined we need to use the product rule for this question. Why? Because the function y is clearly the multiplication of two distinct functions of x, which is our x is 2x squared and exponent sine 3x. Okay, so the formula for product rule is u v prime plus vu prime. Okay, so I already determined the u for our for this equation is 2x squared and our v is exponent sine 3x, and then we need to find the u prime. So the u prime will be 2x squared, so the u prime will be 2 times 2, and then the power will be deducted with 1, so our u prime will be 4x. Okay, clear? Okay, moving on, we need to find the v prime. So firstly, jot down the v, and then we need to differentiate the power for the exponent. So the power for the exponent is sine 3x. So first, after we differentiate, we will get cos 3x, and then we need to differentiate this particular 3x. We will get 3. Okay, so after I rearrange it and already times cos 3 and 3, we will get 3 cos 3x and exponent sine 3x. So this is our v prime. Okay, and then we just simply sub in to the formula. Okay, so this is our u and v prime, and this is my v, and this is our v and u prime. Okay, so the final answer will be 2x squared. This is our final answer. So our final answer will be 2x squared 3 cos 3x exponent sine 3x plus 4 exponent x sine to the power of sine 3x. So that's all. Thank you. Okay, so moving on to the next question, which is 2b. So we got function y equals to 3x squared minus 1 over sine x. Okay, so here we need to determine what rule we're going to use. So I already determined we need to use this quotient rule. Why we need to use this quotient rule? It is simply because the function y is expressed as the division of one function of x by another function of x. Okay, so this is the first x, and we divide it by another x. So that are the definition of quotient rule. So we use this quotient rule, and then the quotient rule formula is vu prime minus uv prime divided by v squared. So we need to determine which are our u and our v. So I put here our 3x squared minus 1 is our u, and our sine x is our v, and then we need to find the u prime and v prime, which is our u prime is equals to 6x, and then our v prime is cos x. Okay, why I got 6x for our u prime? Because I differentiate our u, which is 3x squared, so this power multiply the integer our integer which is 3, so we got 6x, and then the power we need to minus with 1, and then this negative 1 we simply don't write it because it has no x, and then sine x, if we differentiate we will get cos x. Okay, moving on. So here I already sub in our uv and our uv prime into the quotient rule formula. So this is our this is our v, and this is our u prime, and this is our u v prime. Okay, and then we need to minus it, put just like in the formula, and then we need to, don't forget to, this our v we need to has the power of 2 in it. Okay, then our final answer will be 6x sine x minus 3x squared minus 1 cos x divided by sine 2x. Okay, that's all. Thank you.
Today we're going to answer some calculus question. Question 3, find dy per dx in the equation x power of 2 e power of 4x plus y minus c in bracket 3x minus ln y power of 2 equal to 0. We're using the implicit differentiation. So firstly, we need to simplify step by step. Okay, we need to simplify the equation first using the property of logarithm ln a b equal to b ln a. So we can write them in the term of ln y power of 2 as 2 ln y. Say, for example, we got 2x power of 2 e power of 4x plus y minus sin power of 2 3x minus 2 ln y equal to 0. Then we need to differentiate each term with respect to the x. So we need to apply the derivative operator d per dx to the entire equation. So we get dx in the bracket x power of 2 e power of 4x plus y minus d per dx sin power of 2 3x minus d per dx 2 ln in the bracket of y equal to dx 0. So we need to break down this term by term. So we get the first term. What is the first term? d per dx x power of 2 e power of 4x plus y. So we're using the product rule. What is the product rule? Product rule is u v prime equal to u prime v plus u v prime. So we let u equal to x power of 2 v as e power of 4x plus y, u prime as 2x v prime. To find the v prime, we need to use the chain rule. Derivative of u e power of u is u if e power of u prime. So what we get? We get d per dx e power of x plus y equal to e power of x plus y d over dx in bracket 4x plus y equal to e power of 4x plus y 4 plus dy per dx. So we combine this, we get 2x e power of 4x plus y plus x power of 2 e power of x plus y 4 plus dy over dx. So next we see the second term. So the second term we got d per dx d over dx sin power of 2 3x. So we need to use the chain rule twice. So we got sin 3x power of 2. The first layer is 2 sin 3x. We call as the power rule. The second we call the derivative of sin. So we get cos in the bracket 3x. The third is the derivative of the inside 3x equal to 3. So we get the final answer is, we got the result 2 sin in the bracket 3x cos 3x 3 equal to 6 sin 3x cos 3x. In the third term, it's very simple. It is the chain rule because y is the function of x. As we can see, d per dx 2 ln y, d per dx 2 ln y equal to 2 by 1 per y, dy per dx equal to 2 over y, dy over dx. So we need to assemble the equation. We need to assemble the differentiation equation. So what we get? 2x e power of 4x plus y plus x power of 2 e 4 power of 4 x plus y 4 plus dy over dx. We close the bracket. Minus 6 sin 3x cos 3x 2 per y dy per dx minus, this is minus 2 per y dy over dx equal to 0. So we need to expand to isolate the dy per dx. So what we're going to do, we get 2x e 4x power of 4x plus y plus 4x power of 2 e power of 4x plus y plus x power of 2 e power of 4x plus y dy per dx minus 6 sin 3x cos 3x minus 2 per y dy over dx equal to 0. So we need to group it and move it to the right. Move the dy per dx to the right. So what we're going to do, we got x power of 2 e power of 4 x plus y dy per dx minus 2 per y dy over dx equal to minus 2x e power of 4x plus y minus 4 x power of 2 e power of 4x plus y plus 6 in 3x cos 3x. So we got the final answer. Before that, we need to factor. Let me zoom in for you. We need to factor the dy dx. So dy per dx x power of 2 e power of 4x plus y minus 2 per y equal to 16 3x cos 3x minus 2x e power of 4x plus y minus 4x power of 2 e power of 4x plus y. We need to solve for dx, dy per dx. So we divide both sides. So we got dy per dx 16 3x cos 3x minus 2x 4x plus y minus 4x power of 2 e 4x plus y over x power of 2 e power of 4x plus y minus 2 over y. The final answer we get dy per dx equal to y 16 in the bracket 3 sin cos 3x 16 3x cos 3x minus 2x e power of 4x plus y 1 plus 2x over x power of 2 y e power of 4x plus y minus 2. This was the final answer.
Hello, I am NADZMIE and I will answer the question for linear approximation. So the question is, use linear approximation to estimate the value of cube roots of 63.99 plus 1 over square roots of 63.99 correct to 3 decimal places. But we have a problem, which is 63.99 is not a perfect number for cube roots or square roots, so calculating this by hand is difficult. So we need to use linear approximation to find a very close estimate. So first, we need to define the function fx and our base point. I will use a to represent the base point here. So for our function, we just need to write back exactly like this, but the 63.99, we need to replace it with a variable x, right? And then you get like this, and then we need to find our base point. So base point is a number that is very close to 63.99, and I will choose 64 as our base point. So now we already have our base point. We also have our x, which is 63.99. So now we can identify the change of data x. So the formula is x minus a. So our x is 63.99 minus our base point 64, and we'll get negative 0.01. And now here we can now put the formula for linear approximation. Fx equals to fa plus f prime a times delta x. So we need to find one by one. We need to find the fa, we need to find the f prime a, and delta x, but we already have our delta x, which is negative 0.01. So we just need to find fa and f prime a. So for fa, we need to do same like this, but replace 63.99 with our base point, which is 64. Then we just need to solve it, and you will get 4.125. So our fa is 4.125. Now we just have to find our f prime a. For our f prime a, first we need to find the derivative, the slope function, and then we replace with our base point 64. Right? Then you just need to solve it like usual, and you will get 0.01986. That is for our f prime a. Alright, so we already have our fa, we also have our f prime a, and also delta x. So we just need to put it back to our formula. So our formula earlier is fx is our x 63.99, and then fa, our a is 64, and then f prime 64 times our delta x that we got here, negative 0.01. We already count our f 64, we got 4.125 here, plus with our f prime 64, we got 0.01986 times our delta x, negative 0.01. Then solve it like usual, and you will get 4.124814. And then final step is to round the result to 3 decimal places as required by the question. So when we round it, we will get 4.125. So the conclusion is the estimated value of cube roots 63.99 plus 1 over square root 63.99 is 4.125. Alright, that's all from me.